Hey guys, today you join me for episode 3 of Learn to Code with Kerbal Space Program, a series in which I try to show you how you can use Python code to fly rockets around in Kerbal Space Program. Now, last episode we took a look at variables and if statements, and then we used that with a little bit of with a little while loop to fly our rockets around a bit, turn them left and right, and land on the ocean and everything like that. Today we're going to look at more into loops. We're going to look at arrays, and then we're going to write some code that flies our rocket all the way to orbit, which is quite a big task, I'm not going to lie. And it is a little difficult, but I think we can do that today with the knowledge we have. But I think it'll make it interesting so that we can move on quickly and do things. So, like last time, the first part is going to be taking a look at the Python, and then the second part will be flying things to orbit. So actually, if you already know Python, you can just jump ahead a bit and just write the orbital code. But if you're here to also learn Python, just watch the first bit, which will be a little shorter. Learn the stuff, and then we can move on and write the orbit code together. So anyway, let's jump right into it and take a look at loops. So last time we used a while loop, and we just said while true, fly rocket, basically. So let's just say print, let's say print flying. We're flying. And if we run that, what it'll do is, it'll take a little while to run for some reason, and then it'll just print flying forever. If I left this and I had power forever, it would print this forever, until the end of time. Probably not, but it would print for a very long time. So yeah, that's what that does. That's what we did last time, and then we would stop it by hitting Control-C. We would just be like, run this code, I'll stop it myself, it doesn't matter. But ideally, really, you want it to stop itself. And this is, of course, a condition, like I said last time, in the same way an if statement says, if this is true, do this. A while loop says, if this is true, do this until this is no longer true. And what it does, basically, is it checks this is true, and then it runs all of the code inside it, and then it comes back around, and then it checks again. Is it still true? Then it runs all the code inside it if it is true, and if not, and then it comes back around and checks if it's true, and if it's not true, then it just exits and does whatever code's below it. So, that's what a while loop does. So let's give it a condition. So we could say this, we could say A is equal to true, and while A is equal to true. You can use variables and everything, and it's the exact same way you do in an if statement, or while 1 is equal to 1, or while, B is equal to 10. But you don't really want to do that, because those things don't really change. So let's create a variable called num loops, number of loops. Just num, capital L, so that you can see it's a new word, num loops. For now it's 0, because we've had 0 loops. And then we're going to say while num loops is smaller than 10, let's say print num loops, so that we can get a good idea of what's happening. And then we're going to say num loops plus equals 1, because we've just had one loop, so that's an extra number of loops. And then we run that, and it's going to print 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, because obviously it's up to smaller than 10. If we said smaller than or equal to, it would print the 10, but just smaller than 10 is going to print that. And that's how that works. So once this gets to 10, this is no longer true. And then it exits and does whatever's below it. So we could say print done. So it's going to print all the way up to 9, and then it's going to print done. And it's going to do that very fast, of course, because it's a computer. It's extremely fast. But more often than not, actually, with a while loop, you're not just going to be adding stuff like this. Something is going to happen within your while loop that's going to stop your while loop. So what we could say is num loops is equal to 0, and we could call a variable run and give it a value of true, and say while run, which is the same as saying while run is equal to true, just because it has a value of true. So while run, print num loops plus equals 1, and then we could say in here, we could use an if statement and say if num loops is equal to 10, run is equal to false. We're going to say, okay, when it gets to 10, run, we should no longer run, and then we're going to just print ending. And once we run that, let's see what happens. Oop, I've missed myself a colon. always make sure you get a colon. It tells Python that the code below this is what I want to do. That's what the colon does. So let's run that. I'm going to have a sip of water. Apparently I'm losing my voice, which is great. Yeah, you can see what it does. As it goes through, it has a number of loops is equal to 0. So it prints 0, then it adds 1 to it, then it checks if number of loops is equal to 10. It's not, because it's equal to 1 right now, because 0 plus 1 is equal to 1. I know, big maths. Then it comes back around. Am I still running? Yep, run is still equal to true. And it does this until it gets up to 10. Then it prints num loops, which is 9, adds 1 to num loops, which makes num loops 10. And then it says if num loops is equal to 10, it is equal to 10, set run equal to false, and print ending. And then once it comes back around, while run's false, let's do what's below it. And here, actually, we set run to false, so the condition is no longer met. So shouldn't it just stop here? Well, no, because like we've been saying, it runs all of this code and then checks. So it does print ending after it. It's not waiting till the second it's no longer true and then cutting it. It's running all of this and checking at the start of each run whether the condition is met. And yeah, that's a while loop. That's how that works. Now, there is another kind of loop, and it's called a for loop. And we're going to take a look at that right now. So a for loop. What's a for loop? Well, let's take a look. As you might expect, it's denoted with for, because it's a for loop, like a while loop. And then we need to give, in this place where in a while loop we would give it a condition, like for true, or well, while true, we do for I, or well, for a variable name. I'm going to call it I, you can call it anything, you can call it number, you can call it whatever. I'm going to call my variable here I, because I is basically just short for iterator, which is what this is doing. It's iterating through the loop. So we're going to say for I in range 0, 10, print, let's say print I. Let's run that and see what happens. Let's just see what happens first. It'll make it clearer. So it's going to take ages to run for some reason, and then it's going to print 0 to 9. So what is this? For I in range 0, 10. Well, so what we're saying is we're creating a variable I, and for as many times as it is in the range 0 to 10, and this starts with a value of 0. We could also say, I believe, for I is equal to 0 in range. That might not work. Nope, no, it doesn't like that. Okay. So actually, it just automatically sets I to 0. For now, I in range 0 to 10, because this is the first... Shit. So what's this doing for I in range 0 to 10? Well, it's actually kind of doing what it sounds like for variable I in range 0 to 10. So I starts with a value of 0, and it does whatever's in here as many times as is in the range. So for I is equal to 0, until I is equal to 10, do this. And each time, this loop automatically adds 1 to I. It automatically increments it. So here, I is 0, and then it comes back around, adds 1 to it. It's still lower than 10, so it does this again. Print 2, print 3, and then it gets up to 9, comes back around, sets I to 10, and it's like, oh no, it's no longer in the range. I is equal to 10. Let's stop. So basically, you can think of this as the first value of I and the last value of I, the start and the end of your loop. So we could say for in range 5 to 15, and if we run this, it'll print from 5 to 15, well 5 to 14 because it stops at 15. So 5, 6, 7, 8, 9, 10, 11, 12, 14. So this is just the first value, this is the last value, and it will do this as many times as is in this range. So that's basically just how that works. It'll become a little clearer later, as actually quite soon, because we're going to look at this with arrays, which will make this clearer once we've looked at that. Just a note on this though, you can iterate more quickly than 1. You don't have to keep adding 1 to I each time. So what we can do is put a value after this and run this. And you'll see it says prints 5, 7, 9, 11, 13. It's just jumping in 2s. This is saying for I in range starting at 5, ending at 15, going up in 2s. You could also go up in 5s, or whatever you want to do. So yeah, we go up in 5s, and it'll print 5, 10, and then get to 15 and be like, nope, I'm out. Or we could, yeah. So that's how that works. Now I'm going to take you on to the next part, look at arrays, and then we're going to use that with for loops, and that should make this a little clearer, actually. So that's for loops for now, and hopefully it'll become a little clearer later, and for loops are a little confusing at first, but they become you use them all the time in programming, so they become clearer as you use them. Anyway, let's move on and look at arrays and then circle back to this at the end, or loop back to this at the end. I know I'm funny. Alright, arrays. So last time we looked at variables, we could give a variable a value a and set it equal to 10, or b is equal to abc. And that's great, but what if you have a bunch of variables that are basically the same kind of thing? So say we had a score for a game. We had player 1 score is equal to 10. Player 2 score is equal to 30. Player 3 score is equal to, and blah, 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 blah. That's kind of dumb to do it like that, because firstly, what if another player joins? How are you going to code that? And also, this is just not really a smart way to do it. These are all basically the same thing. So what we can do in most programming languages is create an array of variables, which is kind of what it sounds like. It's like a list of variables. So instead of doing this, we could say scores is equal to an array 10, 30, 100, 20, that kind of thing. And the way this is denoted... Oh, leave me alone, Backblaze. Anyway, so the way this is denoted is with these square brackets, and then you give it, you put a value in, and then a comma, and then another value. Again, you can do this as much as you want. You can do, you know, 100, and then blah, 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 and you can just add as many values as you want. But that's the syntax for it. And then if we were to print this, this little array, scores, hit it with an F5, give it a while to run for some reason. It's being very slow today, I apologize. It'll print this array. Okay, great. So, what's the use of this? Well, you can access each of these values. So, I say I want to access the first value. I can type in scores, square brackets, 0, and run that. And it'll print 10. Now, the first value is at the position 0, not 1. 1 will give you 30, because it goes 0, 1, 2, 3. Pretty much, so in most programming languages, arrays start at 0 for just various computery reasons. In some programming languages, they actually start at 1, which is just super annoying, but most of the time it starts at 0. Just remember that. That'll probably catch you out a few times. You'll be like, I want to access the first value, I'll type in 1, but no, it's 0. The arrays start at 0. But yeah, you can see I can access the first element of an array like that, and I could access the... Are you going to run? Yes, very slowly. I could access the third element like this, and well, the fourth element, technically, I guess, and the third element like this. So yeah, we've got a bunch of values in there, and we can add things to that. We can add things to the specific values. So we could say scores 0 plus equals 10. The player just scored. Player 1 just scored. Player 2 just got a triple, no scope, 1080 headshot, 420 whatever, and got 90 points because, you know, you got a 420 no scope whatever. But yeah, so you can add things to individual values of this. And yeah, so that's how you access each value, just with these square brackets, and then you can do whatever you like to them. It's basically like having a variable. Scores 0 is basically just a variable. Scores 2 is basically just a variable. We can also access information about this array. We could find out its length, like how many things are in it. Scores.length. Anyway, let's hit F5. Okay, it's not length, is it? It's, is it size? Oh, bloody hell. Sorry, this again changes for every language. No? Okay. Okay, sorry, no, that's how it is in, like, various other languages. Sorry. In Python, what you would do, if you want to find out the length of scores, you would type in len, and then scores. Now, len is a function, in the same way print is a function. Print, the function print carries out is to print something to this shell right here. The function len carries out is to find the length of this array. We're going to talk a lot more about functions next episode, but that's basically what they do. They are some code somewhere else, you give them something, and they return you something. So yeah, if we run this, you can see, hopefully I'm right this time. Yes, so the length of the array is 4. So we have an array of scores, and like I said, I would come back to for loops. So for loops and arrays go together like carrots and peas. I think that's an analogy, isn't that in Forrest Gump? I don't know, I'm terrible at I don't know analogies. Anyway, so what we can do is say for I, or whatever you want to call it, in range 0 to length, ooh, not Ken, length of scores, print scores I. And we can run that, and it'll print all the scores. How useful is that? And we can actually get rid of the 0, by the way. If you're starting at 0, you don't have to write it. It just assumes. It's like, okay, you're probably starting at 0. So we could actually just do this, and it'll do the same thing. So that's pretty handy. We can look at everything in an array. We could say everyone scored at the same time. We could say, okay, we want to add 10 to each of these scores. Scores I plus equals 10. And then if we print scores at the end, like so, scores, then we can run that. Yes, and then it's added 10 to each one, 20, 40, 110, 30. And you can see I've typed scores I. Now, before we were doing scores 0, scores 1, but you can pass a variable into this. So I could say have a variable called A is equal to 1. I could say scores A is plus equals 10. So say maybe player 2 has killed everyone. He gets 4 more, he gets 40 points. So the great thing about for loops is we have this variable I, so we can use that as the iterator to iterate through an array, to go to each position of array and add 10 to it, or do something to it. So yeah, that's one of the great uses of for loops and scores together. For loops and arrays together. They work fantastically together. So you can store anything in an array. You can store false, true, you know, whatever. You can store a bunch of strings. One, I guess, very uninventive. 2, you know, 100. That's not how you spell 100. You can store strings in an array, and it's great. You can also add things to an array after the fact. So say you've got a bunch of scores, 10, 20, 30, 50. Player 5 joins the game, and you can add to the array by saying scores.append. Let's say he starts with a score of 0. And then we do this, rerun it, and there we go. You can see we've got 10 at the end. So we added 0, we added 10 to all the scores, including the one we just added, print that, and now we've got an extra score 10. Append basically just is appending something or adding something to the end of your array. And that's great because sometimes you need to add another player or add something else to your array. So let's actually let's do something more spacey. Let's write ourselves a launch sequence. So, not like a launch countdown sequence, not the actual full launch sequence. So with this for loop in this array. So what we could do is say print I for I in range, you know, 10. We could print I. And then at the end we could say lift off. There we go. Run that. You know, 0, 1, 2, 3, 4, 9, lift off. Great. That's cool. Whatever. Firstly, that's the wrong way around, and secondly, that's not very cool. So what we could do is have an array of strings with the values in it. No, with the actual words in it. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Lift off. So why don't we do that? Let's just spend a little bit of tedious time adding values to this. 10, 9, 8, 2, 1. Lift off. And let's give that actually 2 words. Lift off. And that's all in the array. I know it's a very long, annoying array. And if we just hit home, that'll take us to the start. And we'll call this countdown. Countdown. And we're going to say for I in range, len countdown. Like so. Print countdown I. And we can get rid of this as well. Then when we run that, it's going to print. It's It's going to take a little while, and this is going to print 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, liftoff. Woo! That's the whole countdown sequence. So yeah, you could do something like that with it. You could print a bunch of strings. Now this is a little boring. Let's actually make this a proper countdown. So what we're going to do is delay, after each of these, have a delay of a second. So it's 10, 9, not 10, 9, you know, it's going to actually print properly. So what we're going to have to do is import something. In the same way we import KRPC every time, we say import KRPC. Now we're going to import time. Now this is just a library in Python that allows us to do things with time, basically. So for example, and what we actually want it to do is say time dot sleep 1. So this is calling a function in time called sleep, which sleeps the program. It just stops it for a bit, and then it takes a value of seconds, and we've just given it 1. So just sleep for a second. Every time you print a countdown thing, sleep for a second. You can also give it like 0.1, 0.0001 if you just want a really tiny sleep time, or you can give it 100 if you want it to sleep for 100 seconds. Be careful though, because if you tell it to sleep for 100 seconds, you can't stop it for 100 seconds. So, well, you probably can in Task Manager, but it's just annoying. So yeah, just do it like this. And then if we hit F5 now, it runs, and we get 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, liftoff. Pretty cool, right? So yeah, that's a good use of arrays and for loops together. Now from here, let's write ourselves. Now we've got a launch sequence, which will probably launch something to orbit, right? So let's do that right now. Okay, so now we've got our little countdown timer. I guess we're going to need a rocket to launch, and then some code to actually launch that rocket. So first, let's go just build a rocket real quick. It needs to be an orbit-capable rocket. I'd suggest doing something fairly similar to mine, or I will just link the craft file if you just want to download the rocket I build, because this the launch code we are going to write should work for pretty much everything, but it's, you know, it's hard to say. Anyway, the last vehicle was called Phoenix 1, so I guess we're going to call this Phoenix 2, and give that a save. So obviously we're launching crew, so we're going to need a launch escape system, because we're all about safety here. So we're going to give it a decoupler there, and then I think the launch escape system is in utility. There we go. We're going to want a heat shield, because I guess maybe we'll come back. We're not going to write the code to come back, but the crew can figure that out. They're smart people. They're smart people. And we've got to have a reason to put crew in there, you know. Throw a not that decoupler. They changed the decouplers at some point, and I'm never going to get used to it. So yeah, then we're going to want a rocket. We're going to want a second stage. I guess 2.5 meter parts is these now? Yeah, that looks about right. Going to want an engine. I'm going to use this nice looking one, the Wolfhound. I guess you could also use the Poodle, but the Wolfhound I think is, yeah, it's pretty good. Yeah, we'll have the shroud on there. Grab ourselves another decoupler. Oh, we've got a decoupler here. Let's just grab that. Oop, pressing all the wrong buttons. Apparently I have a scan complete. Thank you, Malware Bytes. Not sponsored, and probably wouldn't be. I just downloaded it because I managed to get myself some adware, you know, when you just downloading stuff. Actually, I think I got it from the from a piece of software I used to convert some footage for this series. So you're welcome. Anyway, now we've got this little stage here. I'm going to just grab this engine. Not this engine. This engine's terrible. I want this engine? Yes? Maybe? How much thrust does that give? Loads. That's fine. That looks like a good rocket. I'm going to give it some fins just to keep it nice and stable. Like so. And I reckon that is good. Give it some launch clamps, and well, let's put some RCS ports on the pod. I know it already has some built in, but I like to give it these ones because it's useful. And yeah, that's all good. The staging, you're probably gonna want that like that. It doesn't really matter if you have your engines in the stage or after. I think we're probably gonna write code to just compensate for that, but I would just separate them like this. And yeah, there we go. Alright, so let's launch this to the pad and start writing some code. Okay, so basically what we're going to want to do is, well, basically we're going to want to launch to orbit, right? Let's just start our server real quick so we can run our code. So we're going to want to launch to orbit. And what I'm thinking is that's going to take 3 steps. We're going to want to basically do an ascent with a gravity turn. We're going to want to cruise up to our close to our apoapsis once we have our apoapsis in space. And then we're going to want to do our insertion burn. So 3 things we've got to do. So we have our little countdown code here. So the first thing we're going to want to do is obviously import KRPC, same way we import time, and the same way we've been importing KRPC the last couple of episodes. And then we're going to want to get our connection to the game. So con is equal to krpc.connect, and that'll connect us to the game. Then we're going to want to get our vessel. So vessel is equal to con dot space center space center dot active vessel, and that'll get our active vessel, if I can spell it right. Alright, there we go. And then we're going to want to launch the vessel. So the first thing we're going to want to do is going to want to hard code that. We're going to want to say we're going to want to turn on our SAS. Actually, no, we're not going to want to turn on our SAS. I'll explain why later, but for now we don't want our SAS on. So we're just going to want to throttle up because we're using a liquid fuel engine. So vessel.control dot throttle is equal to 1, and then just vessel.control dot activate next stage. And that's good. And let's just run that to make sure it works. Make sure it does just launch the rocket. It's gonna run, hopefully. My Python is being really slow. Oh, it's running a new thing. Apparently I already had this open. Oh, it's doing its countdown. 10, 9, 8, 7. Huh, this might slow us down a bit. But hey, it's doing the launch countdown. That's cool. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Blast off. There we go. Perfect. And the program should have ended. Good. So yeah, there we go. That's the basic launch code that just launches the rocket. We're going to want to keep track of our 3 phases. So we're going to use 3 Boolean variables. We're going to want a Boolean variable for the ascent phase, and that's the first thing we're going to be doing. So we're going to set it to true straight away. Then we're going to want a variable for cruise phase, and we're going to set that to false because we're not in our cruise phase right now. And then insertion phase, and we're going to set that to false as well. So what we're going to do with these is start an ascent phase, and once we've finished our ascent phase, we're going to set this to false and set this to true so that we know we're in our cruise phase. And once this is done, we're going to set insertion phase to true, and once that's done, we're going to set that to false. And when all 3 of these are false, we're going to stop our program. So a while loop isn't going to be while true. It's going to be while ascent phase or cruise phase or insertion phase. So while one of these is true, well, at least one of them is true, that our code will run. And once it's not, once it's ended, we'll exit this while loop and the program will just end. So good. That is basically the start of all of this. So what we're going to want to do is have our 3 blocks of code for our phases. So we're going to have just 3 if statements. If ascent phase, elif cruise phase, and then let's just say elf insertion phase, just to be right. We could just do an else there, but let's just do this. Okay, so like last time where we were checking our altitude, we're going to need to check our altitude because that's how we're going to tell, well, where we are, how much we need to be turning and all of that. So we're going to say altitude is equal to vessel.flight mean altitude, and that's just our mean altitude above the ground. And so this is inside the while loop, so this will get set every time. So every time the while loop comes back around, we're going to set our altitude to this. Whereas since these are set outside outside the while loop, they're not going to set unless we explicitly set them one time in here. So another thing we're going to need is our heading, because we're going to need to know if we're going, if we're turning over at 90 degrees or turning over at 270 degrees, because we're going to want to go up at about 90 degrees. We're going to want to know which way we're going. So heading just gives us a number from 0 to 360, I guess, just basically which way we're pointing. So that is also gotten from the flight parameters of the vessel. So we're going to do this vessel.flight, which calls the flight function, which returns as our flight parameters, and then we're going to get from that the heading. Alright, so now we know how high we are and which way we're pointing. So what we're going to want to do is basically manually do a gravity turn. We're going to want to turn over our rocket. So we're going to want to know what our pitch is, and we're going to know where we want to be pitching. And the way we're going to do that was with a little equation. So we've done operators before, but we haven't really combined them into like a big equation. And we're going to do that a little bit right now. So we want to target pitch. So we're going to create a variable called target pitch in our ascent phase, because that's going to keep changing as we go up. And what we're going to do is I'm thinking we want to be basically going flat at 50 kilometers up. We're going to want to going flat to the horizon at 50 kilometers up. So what we're going to do is find our altitude relative to 50 kilometers, so 50,000 meters minus altitude. That's going to give us a number from 50,000 to 0. So once we're at 50,000, we're going to have a value of 0. And we're going to divide this by 50,000. So that'll give us not just a number from 50,000 to 0, but from 0 to 0. So almost like a percentage of the distance we are up. We're going to know how far up we are. And we're going to times this by 90. So, when you think about this, we get a number between 50,000 and 0, telling us how high we are. We divide it by 50,000, so we have a decimal telling us what kind of percentage of the way up we are. And we're going to times that by 90, giving us a value from 0 to 90, or actually accurately 90 to 0, because we start pointing at 90 and we want to turn over till our pitch is at 0. So right now it's at 90, but once it's on the horizon it'll be 0. So our target pitch is going to lower as we go up, as we go up. So we're just going to try and hit that. So basically what we're going to want to do is compare this to the pitch of our vessel. And if we're below it, we're going to want to turn up, and if we're above it, we're going to want to turn down. Now we could do this with some if statements. So say if our target pitch is, if our current pitch is lower than our target pitch, turn left. If our target pitch is greater than our lower, you would turn right. You get the point. But that's actually not a great way to do it, because then we'll be turning just fully all the time, and we're probably just going to oscillate around the point we want. So what we're going to do is find out the difference in pitch. So we're going to create a variable called pitch diff, or you can call it what you want, pitch difference if you like full words, but I'm just going to call it pitch diff, and this is going to be just vessel.flight, getting our flight parameters again, .pitch. This is how much we've pitched down. Now, this is a little confusing, because if we yaw, surely our pitch doesn't change, but pitch in this context just means how high we're pitching above the horizon. Doesn't matter which way we're rotated, or just if we're here but still rotated to the 90, we're going to have a pitch of 45. Right now we have a pitch of 90. So it's almost like we're flying an aircraft rather than a rocket. Anyway, so that's what that does. And now we have that difference. Oh, we haven't actually done it. Vessel.flight.pitch minus target pitch. So that'll give us our difference. So from that, what we can do is say we want our vessel. Vessel.control.yaw to equal pitch diff divided by 90. So what this is going to do is pitch more when we're further away from our target pitch and pitch less as we approach it. So we won't be swinging wildly, we'll be gently just moving towards our pitch. And dividing it by 90 puts it between 0 and 1, because our pitch control takes a value from 0 to 1. 0 being no pitch, 0.5 being half pitch, 1 being full pitch. So, if we run this, let's just see what happens. So let's run it. Oh, right. Okay, so we actually do need some code here for it to... we just need to put some dummy code in here. So for now, we're just going to type in print cruise phase. This is never going to get run, but Python needs there to be code below its else if statements, or below its statements, because otherwise it's L if nothing. You need it to be L if something. So yeah, let's just type in this. Doesn't really matter. Right. So let's run this code and see what happens. And it's going to do the countdown, obviously 10, 9, 8, 7, 6. I might change that to just like 3, 2, 1 for the purpose of this, but if you want to keep it at 10, 9, 8, 7, 6, that's fine. Anyway, so that'll launch, and you can see it's going to try and turn. But it's actually turning the wrong way, because So it's turning the wrong way and turning too much, because initially it just went to 270, and because the pitch is just the distance from the horizon, it doesn't matter which way it's going. So we're actually going to want to make sure it turns the right way, because this obviously isn't what we want, and it's actually turning the wrong way now, because we've told it to turn kind of the way we'd want it to turn if we were going to 90 degrees. So let's just kill this program really quickly and revert to launch. So we're actually going to want to check our heading. That's where we got our heading right, so that we know which way we're pointing. So we're just going to do a really simple thing. We're going to say, if heading is... Ooh, we don't need the brackets. If heading is smaller than 180, so if it's in this half of the nav ball, do this. Else, vessel.control.yaw is equal to 0.5. So if it's in this side of the nav ball, just turn this way. Otherwise, turn how much we want you to turn. Now, this isn't going to keep it on the 90, but it is going to keep it in this side of the nav ball, which is good enough for now. So yeah, if we launch this, let's see what happens. So it's actually, before I do this, I am just going to cut this down to 3, 2, 1 because I don't want to have to watch that every time. Again, you can keep it at 10, 9 if you really want realism. Anyway, let's see if this works. 3, 2, 1, lift off. And it launches, and it starts turning. Turns a little bit at first, and then oscillates back because it's gone too far. And then it's just going to keep turning over, and it is oscillating a little bit, but not too much, and it does look like it's tracking all the way up. So we're just going to watch this for a while and make sure it does the right thing. You can see it is oscillating off the 90, but that's okay for now. It's still going up roughly in the right direction. And hey, it's fine as long as it's roughly correct. I'm pretty sure that's how NASA does it. They're like, near enough. Anyway, yeah, so you can see it's just turning more and more as we get higher, which is exactly what we wanted. So we can just assume that this is working. We can follow it all the way to 50, but that's going to take a little while. But it seems to be doing exactly what we want. So we're going to kill this program, hit Control-C, and then we're just going to revert to launch. Alright, so we have some code that controls our heading, that pitches over at the right amount. That is great. So, we're going to need to stop at some point, because if we just let this go, it's going to pitch over to 50, it's going to just keep pitching over at 50 kilometers, it's going to start pointing down, or it'll run out of fuel, and we won't really have a target altitude. It's just going to hit a random... It's just going to hit a random apoapsis and do whatever. So we're going to want to check our apoapsis. So let's write a little statement to check that our apoapsis is in the right place. I'm going to go for an orbit of 100 kilometers roughly around Kerbin. So what I'm going to do is say if vessel.orbit. Now this is a lot like flight, but vessel.orbit is our orbital parameters. It's an object holding all of our orbital parameters. So if I say vessel.orbit.apoapsis, that's going to return as our apoapsis, luckily. And I'm going to check, actually not if it's greater than 100,000, because this apoapsis actually comes from the center of the planet, the center of mass of the planet. And the radius of Kerbin is about 600 kilometers. So we're going to set this to 600 plus the 100 kilometers we wanted. So we're going to set it to 700,000 meters. So that's actually going to be an orbital altitude of 100 kilometers above sea level. I know that's a little confusing, but basically when you're doing... So basically everything in Kerbal Space Program is considered just like a point mass. So all of Kerbin's mass might as well be right in the center. So the equations only really work out if you take the distances from the center. That's a little bit of a brief bad description of physics. But yeah, that's why that is. Anyway. So then we're going to want to have a sequence of things that is our main engine cut off and sets us into cruise mode, so that we just cruise up to the apoapsis and then do our insertion burn. So what we're going to want to do here is say vessel.control.throttle is equal to 0. And then we're actually going to want to say time.sleep. Because if you've ever put lots of things in the same stage as in Kerbal Space Program, say a separator and an engine, only one of those things will happen. It'll separate, but the engine won't activate, or something like that. And that's because it happens at the same time. So it separates, but then you don't have control of it, so you can't activate that engine. So what we're going to want to, so it's kind of like that, and what we're going to want to do is sleep for a while. We're going to do another one of these time.sleep. And we're just going to sleep for half a second. And then we're going to want to stage. We're going to want to drop that... we're going to want to drop that first stage. Now, it might still have some fuel in it, but we're not too worried about that because It's very common to drop rocket stages with fuel still in them. In fact, SpaceX does that and lands them. So yeah, the first stage's job is just to do the ascent phase. The insertion phase is done by the second stage. So that's gonna throttle down, wait a little while, then drop that first stage. And then what we're going to want to do is turn SAS on. So I said before, we're not turning SAS on at the start, and that's for a good reason. I found while writing this that SAS is quite strong in the game and doesn't really agree with all of these inputs, and actually pretty much just stops you turning. So we're leaving it off and controlling the vessel ourselves, and that's fine because we can write code to control the vessel properly, so we don't need SAS. But we are going to use SAS for this as a bit of a shortcut. So we're going to turn SAS on. Vessel.control.sas is equal to true. And then we're going to say time.sleep for 0.1 seconds. And this is again just to let the SAS turn on before we do the next thing. Because the next thing we're going to do is turn the SAS mode to prograde. So we're just going to get SAS, the autopilot, to control our vessel for us rather than writing some code that tries to follow the prograde down, because we're going to be wanting to point roughly prograde when we do our insertion burn. So what we're going to say is vessel.control.sas mode is equal to basically is equal to prograde. And the way we do that is we find a prograde object, a prograde value, because there's no implicit type in Python called prograde. We have to get one that's already in KRPC. And the way we do that is we go to our connection, we go to Space Center, so that's where all of the game basically exists. And then there's something in here called SAS mode, which stores all of the different SAS modes. And that's going to set it to, and then we're going to type SAS mode.prograde, and that'll set SAS to prograde. Basically doing this, turning on SAS and clicking this button here. Alright, okay, so now that's done. We're all set to cruise. So we're going to want to tell the program, okay, you've done your ascent, now cruise. Okay, so ascent phase is equal to false. Cruise phase is equal to true. So this is fairly simple. Basically, we follow our heading all the way up and keep turning over more and more until we get to 50 kilometers, and then we'll be pointing sideways. But once our apoapsis is at 100 kilometers, which might be before we're actually pointing sideways, it's gonna anyway, once its apoapsis is at 100 kilometers, we're gonna turn the throttle off, we're gonna activate the next stage, turn the SAS on, and tell it to point prograde. And I'm just going to add another little if in here. You might have 2 stages that get you through your cruise phase, or 3 stages, or however many stages. So what we're going to want to do is just write a little if statement in here that says if vessel.thrust is equal to 0, vessel.control.activate next stage. And that's just going to allow you to do that. Now, this won't work for strap-on boosters, by the way, because once your boosters flame out, you will still have thrust. We might do that kind of thing in the future, and if you really want to, you could maybe try and figure that out yourself. I'm going to link some documentation in the description. If you want to carry this on and figure out when your boosters are flamed out, that'll be a different thing to just checking if your thrust is at 0. Alright, but for now that'll work. For this kind of rocket with no boosters, this is some good stuff. It'll take us all the way up there and lock us to prograde. And we're going to run this and check that it works. But first, I'm just going to show you something called comments. Now, you might be looking at this and thinking, this is a little hard to read. Once I look at this in a couple of days, I'm not going to know what it means. Well, there's a helpful thing in pretty much every programming language that allows you to just leave notes for yourself or for other programmers. So the way you do this is, in Python, is just type a hash symbol, not a hashtag. That is just not what it's called. It's just called a hash. A lot of people would call that symbol a hashtag. No, a hashtag is the thing you do on Twitter. This is a hash symbol. Anyway, and we're just going to write what these things do. So this is our heading control. So we're just going to leave a comment saying heading control. And you can write anything you want in these comments. You could write, well, you can write whatever you want. This is our staging code, of course. We're just going to leave a little comment there that says staging. And we're going to leave a comment here that says MECO, main engine cutoff. Now, yeah, so these are just little comments. The program ignores them. They are just for people to read to make your code a little more readable if it gets a little messy. And hey, let's actually just put up here, flight state. This is our flight state, basically. And hey, might as well put a little comment here saying countdown sequence. Let's hope I can spell sequence. Anyway, yeah, so you can write whatever you want in here. If you type hash symbol, then this line is a comment. If I go below here, no longer a comment, but I could just type another hash symbol and write some more comments. Anyway, so yeah, that's just a little brief aside, something extremely useful in programming, and you want to comment your code so that you know what it means, so that other people know what it means. Anyway, let's run this code and make sure it's all right, and see if it works. Alright, so hit F5, and what we should actually see is after this, it should print cruise phase to the terminal. Alright, 3, 2, 1, lift off. And we get a nice little lift off, and it tips over quite aggressively at first, but then just kind of tapers back. Now this isn't perfect, it is going to keep oscillating all the way up, but it's a nice simple way of doing it. Of course, feel free between this episode and the next just to play around with this and make it as good as possible. This isn't the perfect launch code, by the way. This is some fine launch code. This works, but I'm going to leave quite a few gaps in this so that you can fill it in, so that you can go and kind of do a bit of self-programming. And I'm going to give you some resources in the description just to help you find what you need to find. Anyway. But obviously you don't have to do that. You can just come back to the next tutorial and it'll be fine. But if you're really interested, then you can go ahead and do that. And by the way, this thing we're doing right now, running orbital launch code, it's not easy. If you're struggling with this already, don't feel bad. It's lesson 3 and we're writing orbital launch code. If you're even minorly following this, well done. This took me a few hours on Sunday just to write up. This is not a particularly easy thing to do. Anyway, you can see actually helpfully right now, just kind of naturally because of the way our rocket is, we're turning back more towards the 90 now, which is quite good. Because you can see it has drifted away a little bit. But that's fine for now, and again, I'm going to leave that for you to see if you can fix it. I'll give you some pointers at the end of this, but for now, we're just seeing if this works. Alright, our apoapsis should be getting up near 50. Oh yeah, there we go. We staged, and we're in cruise phase. Cool, let's just check our apoapsis is right. Yeah, about 100 kilometers. Very nice. Staged, did everything. That seemed to work quite well. Alright, let's kill this by hitting Control-C. Anyway, so yeah, that's good. That's got us in a nice suborbital trajectory. Anyway, let's revert back to launch, and then write the rest of the code to go all the way to orbit. So, we're going to want to do something with this cruise phase. Now, the cruise phase is really simple. The SAS is doing all the work for you, so all we're going to want to do is wait until a certain time, and then and then switch to insertion phase. So we're just going to say if altitude, don't need a bracket. You can put it in brackets, by the way, your stuff, and it's how it is in many languages, but in Python you don't need those parentheses. That's why I keep almost putting that, because I write in other languages where after if statements you do have to put all of your stuff inside these parentheses. Don't have to do that in Python, so yeah. Anyway, quick note about why I keep doing that. Anyway, so now we're just going to check our altitude. And for this, I'm just going to say if altitude is greater than 90,000, we're going to switch modes. We're just going to say cruise phase, oh my god, spelling. Cruise phase is equal to false, because we're no longer in our cruise phase. And then we're going to say insertion phase, insertion phase is equal to true. And then we're going to turn our SAS off, because again, SAS really limits how much you can turn, and since we have code controlling our rocket, we really don't need SAS, because it's basically like our SAS, because it controls the rocket for us. Anyway, so we're going to say vessel.control, .control.sas is equal to false, and then we're going to just throttle up, because now we're in the right place to be throttling. So vessel.control.throttle is equal to 1. This will turn our rocket on right now. And I'm going to explain why we're doing that at the end of cruise phase in a second. So now we want to write our insertion phase. This is all very simple, so we can move right on to our insertion phase. So yeah, basically what this is doing is just checking if we're above 90,000 and then just changing states, turning SAS off and flicking the throttle on. So yeah, alright, insertion phase. What are we going to do for our insertion phase? Well, we're actually going to do something not that dissimilar from the ascent phase. We're going to have a target pitch, but our target pitch is going to be 0, because we want our target pitch just to be on the horizon. So then our pitch diff is just the exact same as this. We can just copy and paste this. And in fact, we can copy and paste our heading control. We'll just grab this and throw it down here. Ooh, like so. So that's just the same code, just keeping our heading pointing the right way. It just so happens we're not changing our heading anymore, we just want to be pointing at pitch. So we can just copy and paste that and reuse that code. Alright, and then we are going to want some thrust control. So what we're going to want to say is if altitude is greater than 90 kilometers, and vessel, actually no, because we're already above 90 kilometers, because if altitude is greater than 90 kilometers, if it wasn't greater than 90 kilometers, we wouldn't be in insertion phase, so we don't need to do that. I was thinking that was what we'd need to do, but we don't need to do that. So actually all we need to check is if we're in orbit. So we're actually going to just say if vessel.orbit periapsis is smaller than, I'm going to say 90 kilometers. I think 90 kilometers is a fine place to have our periapsis. It's not a perfectly circular orbit. Again, I'm not writing the perfect orbit code right now. I'm writing some pretty good orbit code that'll fit into a tutorial. Feel free to make it better. And if you do, tell me about it in the comments. I'd love to hear about it. So yeah, we want to say 90 kilometers. But in the same way as we had to say, we couldn't just type 100 kilometers for our apoapsis because it's taking it from the center of mass of Kerbin. We're going to have to add 600 kilometers to that. So we're going to say 690,000 meters. Then we're just going to have our throttle to vessel.control.throttle is equal to 1. Just making sure our throttle stays on. Then else, we're in orbit. We're in orbit. We're going to turn off our throttle. Vessel.control.throttle is equal to 0. And then we're going to end the program, because now we've done our insertion phase, so we're no longer in our insertion phase. We're going to set insertion phase to false, and now all three of these are false, and it'll end the program. So there we go. We are also just going to want some staging code. So if our engine burns out, we're going to want to stage. We're going to want to go on to our next stage. Maybe you have 2 stages for getting into orbit. So we're just going to do that really quickly with if vessel. Actually, we can just copy and paste this, just like that. There we go. And let's throw some comments in here. We've got staging, and I guess this is SECO. I guess this is second engine cutoff. And I'm looking at this, thinking this is wrong, because our throttle is already at 1. I've made a mistake here. So what we're actually going to do is not bother keep setting our throttle to 1. No point in that. We're just going to get rid of this. We're going to get rid of our else, and we're going to get rid of this. And it's just going to be if vessel.orbit.periapsis is greater than 90 kilometers above sea level, turn the throttle off. Okay, so we've got a whole program right here. This should work if I'm not an idiot. So, I mean, it's probably not going to work. So let's talk through this. So obviously we've got our launch countdown. We're getting our vessel. We've done all that before. We're throttling up and launching. We've got our flight state right here. So we start in the ascent phase. We go into our while loop. We get our altitude and heading every time. And if we're in our ascent phase, we're going to set our target pitch to a percentage of basically our distance from 50 kilometers effectively. Find the difference between our current pitch and the target pitch, and then turn towards that. Then try and make that pitch difference 0 by taking the pitch difference and setting our yaw to basically our pitch difference. And if we're pointing the wrong way, just turn the other way. And then we have our staging. So if our vessel has a thrust of 0, activate the next stage. And then we have our main engine cutoff, or MECO. If you watch a lot of launches, you'll be familiar with the term MECO. So if our apoapsis is above, basically 100 kilometers above sea level, or 700,000 meters from the center of mass of the planet, set our throttle to 0, activate the next stage, turn the SAS on and make it point us towards prograde, and then change to cruise phase. And then when we come back around, we're going to be in cruise phase. And then we're just waiting until our altitude is greater than 90 kilometers, and then we're changing stages and turning our engine on. And then we're going to our insertion phase when we come back around. We're going to try and hit a target pitch of 0 in the same way we did before. And then if our periapsis is above 90 kilometers above sea level, we're going to turn our engine off, and then we're done with the program. And if at any time during this our thrust is 0, we're going to stage. Now, just a quick note. Something else is, like I was saying, this code isn't perfect. I'm saying if altitude is greater than 90 kilometers. This isn't going to work for every vessel. Maybe it takes longer to get to orbit. Maybe you're going to a lower orbit. Maybe just this isn't perfect. The better way to do this would be to look for the time to apoapsis. And I'm going to leave some stuff in the description and describe in a little bit how you might do that to make this better, because you might not actually want to go to 90 kilometers or 100 kilometers. You might want to go to 70 kilometers. And by the way you would do that is change this to 67,000. 70,000 meters above sea level. And then this wouldn't make any sense. And you don't want to change this number to, what if you get it wrong? So this would be much better if we were checking our time to apoapsis instead of our altitude. But for now, this is good enough. We're going for 100 kilometers. Let's run this code and see if it works. 3, 2, 1, lift off. And then we lift off. Nice. We turn a little bit, then correct. We have a launch escape system on there, by the way. We're not using that because, well, it's not really important. It's just there for show, really. What we could do, though, if you want to write some code for that, is check if our pitch difference is so far that we clearly have turned way too far away from where we need to be going and we've lost control of the vehicle. Then you could hit an abort button. You could abort the rocket. You could abort the launch even. That'd be an interesting way. So you could check if this pitch difference right here gets too high. Instead of trying to match, you just abort because clearly something's gone wrong. That might be another interesting thing for you to try out if you're really interested in doing some more coding after this. I'm just gonna, yeah, so all of this stuff I'm saying where I'm not doing the perfect thing and you can fix it later, of course, you don't have to. It's not going to affect the next tutorial too much. But if you're really interested and you really want to get stuck into stuff, I'm just going to mention some things you can improve about this code by yourself after. And I think that would be probably the best thing you can do to learn how to code better, learn how to code in KSP better. And that's why I'm doing that, and also partly because it fits into the tutorial better if it's just short, simple code. Anyway, so yes, where's our, let's check our apoapsis right now. It's coming up to 100 kilometers now, so we go back to our rocket, and hopefully we'll get MECO 1. There we go, that's main engine cutoff. Our first stage will fall back towards the ocean now. And you can see the SAS has locked us towards prograde exactly how we wanted. And now we're going to cruise up to 90 kilometers. And I'm just going to do some physical time warp. You hold Alt and press the full stop button, and that'll physically time warp. Which means physics are still on, your code can still control your rocket, but it's just moving time a little quicker. So we're coming up to 80 kilometers now. We're going to throttle back time warp just by hitting comma right now, so that when we get to 90 kilometers, we're traveling at normal time and everything's just normal. That's 88 kilometers. It's 88 miles an hour, Morty. Marty, goddamn. Got Rick and Morty confused. Anyway, so now we're up to 90 kilometers. You can see the rocket is trying to pitch towards the horizon. And it's oscillating back and forth, which isn't actually exactly what I wanted to happen. So it's actually oscillating a lot more than we'd like it to, and this isn't very good. And I've actually missed something. This actually wasn't supposed to happen, but it's a teachable moment. I've clearly missed something. At some point, we're going to want to lock our SAS. So we're going to want to go back and fix this. So I'm going to hit Control-C, and we're going to leave this and revert to launch. So the way we're going to fix that oscillation is we're going to put a little extra thing on our heading control. We're going to say if we're pretty close to pointing at the horizon, lock SAS, keep us pointing that way. And that's just going to be done with another couple of if statements. So we're going to say if vessel.flight.pitch is equal to, is smaller than 1, or, and vessel.flight.pitch is greater than -1, vessel.control.SAS is equal to true. Else, vessel.control.SAS is equal to false. So what this is doing is checking if our pitch, our distance from the horizon, is basically smaller than 1. If we're within 1 degree of the horizon, turn the SAS on, otherwise turn it off. So basically, instead of oscillating, now it's going to go down to the horizon, get to the horizon, and the SAS is going to lock us in place. So yeah, that's what that's going to do. Let's run that and see if it works. You can see I may have tried this before and gotten some things wrong, but I fixed that as well. Bugs will always appear in code, and yeah, we didn't want it oscillating back and forth. We want the SAS on. when we're pointing in one direction, when we're not constantly turning. We want the SAS just to hold us there. Now maybe it'd be a good idea to write the code ourselves to hold it there, but for now I think it's probably just good to use SAS because it simplifies it. I'm looking at the time on the recording right now. In my naive brain while planning this series, I was like, maybe 15-minute, 20-minute episodes would be good, and this one's probably going to be closer to an hour. I didn't think of it that well. Obviously it takes a while to teach this stuff because I'm showing you Python and then how to use that Python. It makes it a long tutorial. But I'd rather it be long and thorough rather than, you know, just clickbaity and short and easily digestible. I want people to, you know, learn things. I think a good way, if this is too long for you, is to watch the first bit about the Python at one time and then watch the bit about the KSP code, the KSP part, a separate time maybe. And if these are getting too long, just tell me and I will do my best to cut them down because I do ramble a bit. If I'm just rambling too much and being too detailed, then tell me. I'll sort it out. But anyway, enough of talking about the videos. We're coming up on Miko. That'll be our main engine cutoff, and that'll happen any minute. There we go. Miko has happened, and we have locked into cruise mode. And now let's just time warp up to 90 kilometers above the surface. Okay, that's 85 kilometers, and hopefully this is going to work, because I want to go and play Red Dead Redemption. Yeah, that's why this video didn't come out on Monday, by the way. Not because I'm busy, because I'm playing Red Dead Redemption. It's a higher priority. Anyway, you can see now that our SAS is engaging when we're close to the horizon, which is minimizing our oscillations, slowing it down until eventually it'll be low enough that the SAS will just stay on. Now again, that's not perfect, actually that's not amazing, but it does seem to work. Anyway, let's go to map view now and see how our orbit's coming along. Not ideal, actually. It looks like our apoapsis is moving away from us, and our SAS is turning on and off, but that's fine. You could actually just remove this, and it would probably still work fine. Just remove the bit that turns the SAS off, but it seems to be doing the job quite well. Anyway, yeah, our apoapsis is moving away from us, which isn't ideal. Ideally, we would be burning down a little bit, but that requires a little more complicated logic, so I haven't written that today. But again, maybe that's something you could figure out if you really know what you're doing. Anyway, so it looks like we're going to get into orbit now, and hopefully it will be circular enough that, that the code will stop. And yeah, it's getting up above 80, 90, and we're in orbit. Not a perfect orbit, 294 by 90. Definitely not the perfect orbit, but that is some code that can get you into orbit. And yeah, that's the end of today's episode. I hope you've enjoyed it. I hope it's been helpful. I hope it's been clear. Like always, if it isn't, just ask me anything you need to ask me in the comments. Yeah, now we're in orbit. And again, there's a lot of things you can improve about this code. That is part of why I left it how it is. It's not perfect because I want people to improve it so that they can learn, and also because any more complicated than this video would have been 2 hours long. So the things I mentioned that you might want to improve is not just going to 100 kilometers, because you could change this quite easily. You could change this to 670,000, which would take you to a 70 kilometer orbit, or maybe something like 675,000. So you can just change that number to change where you want your orbit to go. But of course, then you're going to want to change your cruise phase. And you could just change this number. You could go to an 80 kilometer orbit, or a 90 kilometer orbit. You could change this to 690,000. That's, no, 690,000. And then maybe you could just say 80,000. So once you're at 80,000, start burning, and that will be fine. But maybe you want to change this to orbital period, to the time until apoapsis, maybe until 30 seconds before apoapsis, or 20 seconds. I will leave some links in the description for you to look at to maybe help you along with that. If you need any help with it, just leave some comments and I will try and get around to them. I don't know how many there'll be. The other big thing you might want to improve upon is the heading. You could see that we aren't in a perfectly equatorial orbit, and you might want to go into a perfectly equatorial orbit, and that's because we don't fix our heading to 90. We just say if it's you know, completely the wrong way, turn the other way. But what you could do is check if your heading is greater than 90 or smaller than 90, and if so, pitch one way or the other to try and correct it. Again, I will leave some links in the description so you can look at it. That might help you along. But yeah, do those kind of things if you're really interested. But anyway, for now, I hope you've enjoyed this. This has been episode 2 of Learn to Code with Kerbal Space Program. I will see you next time.